This presentation is from the Properties of Matter unit for the N5 Physics course, and will be mainly about Gay-Lussac's law. The question, what is temperature, has a very specific answer in physics, because temperature is defined as the mean kinetic energy of the particles in a substance. Keep thinking about moving particles for the next few slides. We normally say it's freezing when the temperature is 0 degrees C. But by our definition of temperature, at 0 temperature, particles will stop moving and have no kinetic energy. The next slide shows that we have a problem. So, freezing happens at minus 273 degrees C, or more accurately, 0 kinetic energy happens at minus 273 degrees C, because absolutely no particles can move at that temperature. Rather than saying minus 273 degrees C, physicists normally say this temperature is absolute zero. Some things you might want to know about Lord Kelvin. His real name was William Thomson, and he was born in Belfast but studied at Glasgow University. Read through the slide, become familiar with the conversions from degrees C to Kelvins, and from Kelvins to degrees C, and then try the questions on the next slide. There's no need to copy this table, just try all the conversions. You might want to pause the slide while you're trying the conversions. How did you do? Remember, going in one direction you add 273, and going in the opposite direction you take away 273. Familiarise yourself with this diagram. The gauge at the top right is designed to measure pressure, and the thermometer measures the temperature of the air in the flask. Compare the left-hand column, pressure, with the right-hand column, temperature in kelvins. This is simple language to explain Gay-Lussac's law, simpler than is acceptable for N5, but it should get the idea of the relationship between pressure and temperature across to you. The next slide shows a further analysis of Gay-Lussac's data. The line on the graph can be extended to the origin because the temperature scale is in Kelvins. Remember, graphs are a very common multiple choice question. Having read this slide, you should now be able to quote Gay-Lussac's law. Remember, when quoting any gas law, you should mention mass, pressure, temperature, and volume. So a good statement of Gay-Lussac's law would be, assuming there is no change in volume or mass, pressure is directly proportional to temperature in kelvins. You might want to pause the slideshow and write that down. The left-hand box reads as pressure is directly proportional to temperature. The other two boxes are very useful for calculations. And if you note this time, P1 and P2 do not have a unit, but T1 and T2 absolutely have to be in kelvins, or your calculations will not give you the correct answers. Again, once you've familiarised yourself with this slide, it might be worthwhile pausing it and writing it out. The statements in this slide are the ones that we would be accepting for A-type explanations of Gay-Lussac's law. Read the question carefully before examining the solution. The temperature has to be in kelvins for the calculation to work. That's why 310 is used for T1 and 350 is used for T2. Again, read this question carefully. For any Gay-Lussac's calculation, temperature must be in kelvins. T1 therefore is 295 and T2 is 310. Again, read the question carefully. You must change 20 degrees C into kelvins before attempting to use the equation for Gay-Lussac's law. In this example, because temperature is in degrees C in the question, it's good practice to give your final answer in degrees C as well. There is no need to copy out this table, but you might want to pause the slideshow, do the 6 calculations, and then check your answers on the next slide. To make your life simpler, all the temperatures are already in kelvins. Here are your answers. How did you do? Pause the slide and check. Having any difficulties, just get in touch.